Imagine a world unlike any other in our solar system, a place far beyond the familiar sights of Earth, in the cold, dark reaches of space. A place where violent winds, frozen clouds, and strange, shifting gases dominate the landscape. This is Uranus, a gas giant shrouded in mystery and wonder. But what if we could not just visit, but live here? What would it be like to build a life on a planet so far from Earth, in a world where the very laws of nature seem unfamiliar and extreme? Could humanity ever adapt to the challenges of such a distant and hostile world? Uranus, the seventh planet from the Sun, sits in the outer reaches of our solar system, far beyond the familiar bounds of Earth. It's a world unlike any of the rocky planets we know, and it's vastly different from the gas giants like Jupiter and Saturn. Uranus is made mostly of hydrogen and helium, along with a cocktail of icy materials like water, ammonia, and methane. Its composition and atmosphere make it a place unlike Earth, a world where survival would require an entirely different way of thinking. At its core, Uranus is a massive ball of gas. It doesn't have a solid surface like Earth, which means the concept of living on the ground simply doesn't exist here. Instead, if we were to live on Uranus, we'd have to construct floating colonies in its thick, volatile atmosphere. These floating cities could be suspended high above the planet's swirling clouds, in the upper layers where pressure and temperature are more manageable. In a way, life here would be like living in an artificial habitat, suspended in the very breath of the planet itself. But surviving on Uranus isn't just about overcoming the lack of a solid surface. The atmosphere here is a nightmare for humans. It's made of methane, ammonia, and other toxic gases. There's no breathable air, no oxygen. To live on Uranus, we'd have to build self-sustaining ecosystems within the floating colonies. Our homes would need to be completely sealed off from the outside, with sophisticated filtration systems to remove the harmful gases and generate oxygen. Artificial biospheres could be the key, where everything from oxygen to food would need to be carefully regulated. Air would be pumped in, plants would filter out carbon dioxide, and the temperature would be controlled to keep us from freezing in the frigid environment. Now, the weather on Uranus is something truly alien. The planet is freezing cold, with average temperatures around -224 degrees Celsius, -371 degrees Fahrenheit, the coldest of any planet in our solar system. Imagine stepping outside into an environment where everything, from the air you breathe to the ground you walk on, would be an endless chill. And yet, this freezing world is home to some of the fastest winds in the solar system. These winds can reach speeds of over 900 kilometers per hour, 560 miles per hour. It's like living inside a perpetual hurricane, where the atmosphere is in constant motion. These high-speed winds would create constant challenges, especially when it comes to building structures that can withstand these forces. Any floating colony would have to be incredibly durable, designed to absorb the shocks from winds that could send debris flying at supersonic speeds. But these winds don't just create a challenge for construction. They also pose a problem for the day-to-day life of the colony's inhabitants. Long-term exposure to such extreme conditions would require that all infrastructure be insulated and protected. Shielding from the intense radiation of the sun, which is weaker at Uranus's distance, would also be a concern. We'd need thick protective barriers to filter out harmful solar radiation. The energy systems for a colony on Uranus would likely depend on nuclear power, as solar panels wouldn't generate much energy so far from the sun. The idea of using natural resources from Uranus itself, such as its methane-rich atmosphere, could even play a role in providing power, through advanced chemical processes that could convert these gases into usable energy. And then there's the challenge of Uranus's unique tilt. The planet is tilted almost 98 degrees on its axis, causing it to roll around the sun like a barrel. This extreme tilt means that each pole of Uranus experiences 42 years of continuous sunlight, followed by 42 years of complete darkness. For those living on Uranus, this would completely change the way we think about time. Imagine living in a place where daylight lasts for decades, only to be followed by a long, dark winter. The psychological and biological effects of such a phenomenon would be profound. Would we need artificial light to mimic the Earth's day-night cycle, or would our bodies adjust to the long stretches of sunlight and darkness? These questions would likely become a central focus for scientists studying the feasibility of life on Uranus. But perhaps one of the most intriguing possibilities for living on Uranus involves its moons. With 27 known moons, many of them could become hubs for human exploration or even settlement. Some of these moons, like Miranda and Ariel, have landscapes that are both breathtaking and mysterious. Miranda's surface, for example, is filled with dramatic canyons, ridges, and a chaotic geology, suggesting the possibility of an ancient cataclysm. Other moons like Titania and Oberon are ice-covered, with the potential to harbor subsurface oceans beneath their icy crusts. Could these moons contain the raw materials necessary for supporting life, like water and minerals? Could one of them become a secondary base for humans, serving as a mining outpost or a research facility where we explore the secrets of the Uranian system? And then there's Uranus's magnetic field, which is unlike anything we see on Earth. Most planets, like Earth, have magnetic fields that are aligned with their rotational axis. But Uranus's magnetic field is tilted at an odd angle of about 59 degrees, creating an unpredictable and chaotic magnetosphere. Understanding Uranus's magnetic field could be key to learning more about the planet's core and how magnetic fields are generated in gas giants. A mission to Uranus could yield valuable information about planetary magnetic fields, the behavior of solar winds, and the processes that lead to the formation of planets and stars. Living on Uranus would be a monumental challenge, but it's a challenge that could yield incredible scientific discoveries. The technologies required to survive would be cutting-edge and revolutionary. Floating colonies, advanced life support systems, and self-sustaining ecosystems would become the foundation of human life on this icy giant. But in the process, we would learn more about how to survive in the harshest environments, how to adapt to strange planetary conditions, and how to harness the unique resources available on Uranus and its moons. This journey wouldn't just be about surviving. It would be about thriving in the most hostile environment humanity has ever encountered. What would it be like to live on Uranus? It would be unlike anything we can imagine today. Yet, in the pursuit of knowledge and survival, humans have always ventured beyond their comfort zones. The distant reaches of our solar system, full of gas giants, ice worlds, and unexplored moons, offer a new frontier, waiting for discovery. And as our technologies advance, the dream of living on planets like Uranus might one day become a reality. Whether it's floating high above the violent atmosphere or establishing outposts on its moons, the future of humanity could one day lie among the stars on a distant, frozen giant.